Hello everyone. I am going to start a new topic for you people, which is related with relation. This one is inverse of a relation. Okay, how can we find out the inverse of any relation? Here in this one video, we'll discuss about the definition of an inverse of a relation, and few examples which are related to inverse relation. Very simple topic. Just go through the steps. I will explain step by step. Okay. First of all, we will try to explain or we'll go through the definition of what is actually inverse relation. Already you have got the basic idea. We have the basic idea about relation. Relation is nothing but a subset of the Cartesian product of the two set. Okay. As Cartesian product itself is a set and it always contains ordered pairs. That's why relation always contains ordered pairs. Okay, so what is the definition of relation? The definition of relation is that definition of inverse relation. An inverse relation is the set, remember, because relation itself is a subset of the Cartesian product of two set. So that's why relation itself is a set. Because subset of the Cartesian product of two set itself is a set. Subset itself is a set. Cartesian product or subset holo hira set hoy. Hekane relation jehetu Cartesian product or subset. Hekane relation okata set hoy. Aru interesting kotha, he relation to jitu inverse hoy, hiu eta set hobo. An inverse relation is a set of ordered pairs obtained by interchanging the first and the second elements of each pair in the original relation, and it is always denoted by R inverse. So what does it mean actually? Whenever it is known to us, the relation always contains ordered pairs. If we will interchange the first and the second elements of each pair, the pairs, the relation contains, obviously it will contain, if it is not an empty relation, then obviously it will contain some ordered pair. If we will interchange the first and the second component of each ordered pair, then obviously a new set will form which contains the ordered pairs which are a reverse of the original ordered pairs. And that relation will be considered as inverse of the original relation and it will be denoted by R inverse. For example, let us consider, suppose R is a relation on a set, suppose, which contains 1 to 3 three elements are there. Suppose the relation contains 1, 2, 3, 1, suppose 2, 2. Whenever we have to find out the inverse, that is R inverse, what we will do? How many ordered pairs are there in relation? 3 ordered pairs. In inverse also it will contain only 3 ordered pairs. But remember that what is the sense will be there in R inverse. We will try to write down the given ordered pairs of the relation R in such a way that the position of the first component and the second component will be interchanged. 1, 2 will convert it to 2, 1. It will be 1, 3 and it will be 2, 2. Because the inverse of or interchanging the first and the second component, 2, 2 will be remain same. And this is R inverse. We know that what is the domain of a relation? The related elements of the first set are known as domain elements. How many domain elements are there? 1, 2 and 3. 1, 3 and 2. This is the domain. Domain of R is equal to what? It is a set which contains 1, 3, 2. Okay. What is the domain of R inverse? Domain of R inverse will be 2, 1. Because 2, 1, 2. Okay. What is the range of R? Range of R means second components, 2, 1. What is the range of R inverse? Range of R inverse means the second components, 1, 3, 2. 1, 2, 3, 2. So if you observe carefully, the domain and range will be interchanged. Iman bilakole na jao. R jitu relation hobo, jitu ordered pair contain kore, tar inverse or tar opposite, that means reverse ordered pair bilak contain koribo. 2, 1. 1, 3 and 2, 2 reverse ho jay. Aru interesting kotha, original relation to jitu domain asil, hetu amar R inverse or range hobo. Okay? Aru original jitu relation or range asil, hetu amar R inverse or ki hobo? Domain. So these are the basic concepts. So what you have to do actually, one relation will be there. We'll try to rearrange the ordered pairs. In such a way that the first component will become the second component and the second component will become the first component. It will be considered as the range. Okay, inverse of a relation. Let us consider few examples. So example number 1, what is there? Let R be a relation on A. Obviously R is a subset of what? Across A. Obviously across A subset of across A contains all those ordered pairs where the first component always belongs to the set A and the second component belongs to the set A. That's why the relation, as R is a subset of this one, R also contains ordered pairs, and it will contain all those ordered pairs where the first component as well as the second component belongs to the set A. So how many relations we can introduce between A to A? Obviously this is nothing but a subset of across A. How many elements will be there in across A? 3 into 3. 9 elements will be there in across A. So how many subsets will be there? 2 to the power 9. Okay. Out of 2 to the power 9, I have considered one relation. That means one subset of across A. Across A subset 2 to the power 9 ta thakibo. Tare bhitor moi eta subset consider korisu. 1, 2, 2, 3 and 3, 1. What is R inverse then? Obviously it will be 2, 1. 3, 2. It will be what? 1, 3. Okay, let us consider another example. Let R be a relation on A, correct? Such that, and the relation is like that 3, 1, 2, 1, 2, 2. Now we'll try to find out a domain, range, and R inverse. Okay, domain, range, and R inverse. First of all, we'll try to find out a domain of R. So, domain of R. What is the domain? This is nothing but the first components only. 3, 2. What is the range of R? 1, 2. What is R inverse? R inverse is nothing but the collection of all those ordered pairs which are the reverse of each and every ordered pair. 3, 1 will become 1, 3. 2, 1, 1, 2. 2, 2, 2, 2. So this is the. So thank you so much for watching the video. So before giving the conclusion to this video, I am going to explain once again what is actually inverse of a relation. Inverse of a relation is nothing but the set which contains all those ordered pairs which are the reverse of the ordered pairs which are there in the original relation. That means ki koribo lagibo ami ordered pair bilakor component bilak interchange korile hobo. The domain of the relation R will become the range of the relation R inverse, and the range of the relation R will become the domain of the relation R inverse. So thank you so much. Thank you once again.